Exercise B2. Exterior angles of triangles. 1. Determine each unknown exterior angle. Show your work. We learned in the lesson that the exterior angle opposite from the other two interior angles are related by adding the two interior angles together. So it is 74 degrees plus 44 degrees will give you the size of the exterior angle CAD, which is 118 degrees. In question B, we know 24 degrees and 48 degrees are two interior angles in triangle HJK. Adding up 48 and 24 degrees will give us the size of the exterior angle across from them, which is angle JKM. It is 72 degrees. Part C. We are shown an isosceles triangle, QRS. Angle Q and angle S will be equal to each other as base angles. So to find the size of the exterior angle QST, we first need to find the size of X. We can say that 2x plus 106 degrees is 180 degrees as sum of interior angles in a triangle. 2x is 180, take away 106. So 2x is 74 degrees. Divide both sides by 2. X is 37 degrees. So the exterior angle QST can be found using supplementary angles. 180 degrees, take away 37, that's 143 degrees. Alternatively, you can also say that exterior angle QST is opposite from 106 and 37. So you can add 37 to 106 degrees, which is also 143 degrees. Question 2. Determine the unknown interior angles. Justify your answers. So part A, we are looking for angle BAC and also angle C. Let's start by finding angle BAC. We see that angle BAC is right next to 125 degrees and they make a straight line. So we can say that angle BAC plus 125 is 180 because of supplementary angles. So we subtract 125 from 180 to get angle BAC equal to 55 degrees. Once we know angle BAC is 55 degrees, we have options to find angle C. The most straightforward option for most of us is to see that angle C plus 70 degrees plus 55 degrees make up 180 degrees because of angle sum of triangles. Add the two known angles, 70 and 55 degrees, that gives 125 degrees. Angle C will therefore be 180, take away 125, which is 55 degrees. You could also find angle C by using exterior angle of a triangle because 70 plus angle C is 125. So you do some subtraction there. Part B. We are looking for angle FGE, so right here, and angle F. Angle FGE is situated next to 120 degrees, making a straight line. So once again, we can use supplementary angles. So 180 take away 120, it is 60 degrees. So here we're going to see how we can use exterior angle theorem to find the missing angle F. We know that angle F plus angle 41 is equal to the exterior angle 120 degrees. Therefore, angle F is 120 minus 41, which is 79 degrees. You could also use the sum of interior angles in a triangle, so 60 plus 41 plus angle F equaling 180 to find the same answer. 3. A carpenter uses an L square to measure the timber for a rafter. The ridge angle is 130 degrees. What is the plate angle? In the diagram given to you, let's label what we know. Here is the ridge angle, so we can mark its size 130 degrees on the diagram. Now we know that this little angle inside, and we call it A, forms a straight line with the ridge angle 130 degrees. So take away 130 from 180. The size of angle A is 50 degrees. Once I know that this is 50 degrees and the triangle here is a right triangle, A plus 90 will give me the exterior angle over here. And then to find the plate angle, we will have to subtract the result from 180. So here the written part is incomplete because it only found this outside obtuse angle is 140, and in reality the plate angle is the supplementary angle to 140, which is 40 degrees. Number 4. Determine the angle measured or indicated by each letter. Show steps in a space. Write final answers in a box. Remember, you can use any angle rules that you have learned in all of your math classes. And you can mark up the diagrams to make things more clear for you. To find angle X, I need to relate that to the inside angles. Therefore, I need to find 180 minus 85, which is 95 degrees, and 180 minus 150, which is 30 degrees first. I add these up using exterior angle theorem to know that angle X is 125 degrees. Later, you're going to learn another way to find X, which might be a little quicker. Diagram B. Here we have an isosceles triangle, and with the 70 degrees here, I know the inside top interior angle in the triangle is 110 degrees because it's 180 minus 70. And then using interior angles, I can say that 2A, because 2 of A, plus 110 is 180. Subtract 110 from both sides. 2A is 70. Divide by 2. Angle A is 35 degrees. Both X and Y are complementary angles to A. So that means we can subtract the size of angle A, 35 degrees, from 180 degrees to get the size of angle X and angle Y, which are both 145 degrees. Part C. There's a lot going on in this diagram. What seems to be the most obvious to you? You can always start with that part. Sometimes if you find that looking for an angle, even though it's not what you need to answer, will help you down the road, you can also calculate the size of the angle as well. So here, the most obvious may actually be angle Z, because it makes a supplementary angles with 38 degrees. So angle Z is 180 minus 38, which is 142 degrees. And then I see there is an 85 degrees over here. We can either make use of the 95 degrees, a complementary angle, and 38 degrees, plus X to get the size of angle X. That's 47 degrees. And I can also use the exterior angle theorem to find the size of angle Y. Because now I know that the 95 degree angle here is supplementary to 85 degrees. If I add this up to 38 degrees, I will get the size of the exterior angle Y, which is 133 degrees.